Hello, am I audible?
Yeah, you are audible.
In recursion, generally, I don't face much problems. I face problems in backtracking. To be honest, in the implementation, I can't. I'm not able to imagine the backtracking part, the
Okay.
backtracking code part. Recursion, I guess, I have a good intuition because of the principle of mathematical induction.
Okay. Okay. So in backtracking, you are not able to visualize the whole part, right? Like,
Yeah, I mean, I'm not able to understand that how is actually the stack is working at the time of backtracking. The particular line that we add in backtracking to backtrack that one line.
okay, got it. Anyone, any other doubts?
And sometimes conversion also creates an issue. For
Conversion as
example,
in?
you have a iterative solution and you want to convert it to a recursive solution.
Hmm.
So sometimes that recurrence relation, whatever you find out it, so sometimes it takes a lot of time or it becomes a complex to get like come up with that single line that creates a recursive relation.
Okay.
And sometimes it's for few questions it is easy to understand actually recursive solutions, but then when we are trying to convert to the iterative approach, then it becomes a challenging sometimes. And that's a opposite thing, but yeah, that's also becomes challenging sometimes, not for all the questions.
Got it. Okay. So today we will discuss three things. First of all, what is a base case? Then how to make the recurrence relation, which you just told right now. And after that we will extend it to how we can use this thing for backtracking and brute forcing. Okay, so backtracking is basically brute forcing. Okay, uh let me just, yep, let me use this. Yeah, recursion. In recursion we will be using base case, relation, recurrence one, and we will extend it to backtracking. Okay, so first of all, like, who doesn't know what is recursion? Okay, so let's say I have a function with a parameter x. Okay, so if within the function itself I call the function again, let's say with some other variable y or something else, so it's called backtracking. Sorry, it's called recursion. Okay, so when a function calls itself, it's called recursion, to be very honest. Now so basically, how does this stop? So if the function keeps on calling itself, so we need a point to stop, right? So that stop or that base condition helps the recursion to come to a stop at a certain point. Okay, so let's say if in this function x, I call function y, so it will infinitely keep on calling the function within itself, right? So I need a condition to stop somewhere. So if I tell that if x is equal 0, let's say return. Okay, so when x is 0, I terminate the function. Otherwise, let's say I tell that call this function again with the parameter y, where y is equal to x minus 1. Okay, simple thing. So this x equals to 0 is the base case. uh, can anyone tell what's the recurrence relation here? Uh, let's say what's the recurrence relation here? Like, how are we decrementing, or like how are we arriving at the base condition?
Like X is being decremented at every step.
Yes, so it will run for x times. Okay, so okay, so the time complexity of this is O of x. Understood? Now let's take a proper real life example. Let's say I am calculating the permutations. Okay, so first things first, before writing any recurrence or recursive code, make sure you are doing three things. First, you are identifying the base case, or before even base case, you are identifying the recurrence relation. Okay, then you are identifying the base case. Okay, and then you are estimating the time complexity. Okay, so someone quickly tell me what will be the recurrence relation in case of permutation. Let's say if I want to calculate the factorial of x, how can I relate it with x minus 1?
X into x minus 1.
Cool. So let's say if I denote a function fx, that will give me the factorial of x. Okay, so can I say that fx is equal to x into fx minus 1, right? Correct?
Yes.
So simple thing, I will have a function called let's say a fact, or let's say factorial. I will take the value as x, which is my parameter. What will be my base condition? So first part is done. What will be the base condition? Come on guys, fast. This is an easy problem.
So when x will be 0 or 1, we'll return the
Simply
1.
I can say that if when x is 0, we know the answer will be 1. We don't need any other uh, I would say computations, right? So if x equal to 0, we return 1. Otherwise we will use this recurrence relation, right? Return x into factorial of x. So that's how you convert a recurrence relation plus a base case into a recursive code. Okay, now let's say if we want to dry run it. Okay, let's say if we want to dry run it, how do we do that? So for that, like, we need to draw the recursion stack. Like, most of you have an idea, right, what is a recursion stack is? Yes or no?
Yeah. Yeah.
Yep, cool. So let's say the value of x is 5, or let's say the value of x is 4. Okay, so initially in the stack, at the bottom we will have factorial 4. Okay, now what factorial 4 will do? The base case it isn't met, so it will call 4 into factorial 3. What will factorial 3 do? It will call 3 into factorial 2. What will factorial 2 do? 2 into factorial 1. And factorial 1 will call 1 into, let's say, factorial of 0. Okay, so this is how the recursion stack forms. Now factorial 0 hits the base condition. Okay, that if x is equals to 0, we return 1. So it returns 1. So now 1 into 1, we get 1. So factorial value is 1. So 2 into 1 we get as 2. Factorial 2 value comes out as 2. 2 into 3 is 6. Factorial 3 value comes out as 6. 6 into 4, 24. Okay, so thus we get the value of 24. So the process we did right now comes under recursion stack. So factorial 4 calls 3, 3 calls 2, 2 calls 1, 1 calls 0. Okay, so factorial 0 is evaluated at first. Okay, so the function which is called at the last gets evaluated at the beginning. Okay, so factorial 0 gets called at the last and gets its original value, which is 1, at the beginning. Okay, then factorial 0 returns the value to factorial 1. 1 factorial 1 returns the value to factorial 2. Factorial 2 returns the value to factorial 3. Factorial 3 returns the value to factorial 4. Okay, so that's how it goes, like last in first out. Clear? Cool. Any questions till here? Otherwise we will solve a certain problem.
No.
Okay, so let's discuss that problem of letter combinations of a phone number. Okay. Before that, let's discuss a bit of backtracking as well. Okay. Now, what is backtracking? So, let's say I am at a certain state. Okay, this is where I am currently. Let's say this is my present, and I want to reach this desired state, or let's say final state. And there are certain intermediate states or steps between it. Okay, let's say these are some intermediate states. Okay, I want to reach from present to final through this intermediate steps. Okay, so what we do in backtracking is that from present we go to this, let's say, any one intermediate state, and see that whether we can reach it to final or not. Let's say we reach final state here. Okay, so here we have explored one way. Okay, next we will reverse the last step. We are reversing this last step. Okay, and then see that from this intermediate state can we go to another intermediate state or not. Let's say we go to here, and from here we go to here. Okay, so that's another way of reaching final. Okay, now let's say instead of going to this, we have gone to this. From here we have gone to this, and from here we have gone to final. Okay, so this is one more way. So let's say from this state, instead of going directly to final, we now go to here, and from here we go to final. Okay, so backtracking is all about that you have a certain step. So let's say from A you go to B, from B you go to C you go to D. Okay, so after finding a valid step, or let's say a valid path, you undo or like go back to the previous state and explore the other options. Like from D you go back to C and explore the other options, that whether from C you can go to any other states or any other positions or not. For example, from C now you want to explore E. Okay, so after exploring E, you again go back to C and say that from C whether I can explore any other state or any other path or not. Okay, so backtracking is every time you reverse the last step and see that what more options can you explore. And backtracking is brute force, so you explore like all the paths. So backtracking time complexity is exponential. Okay, so backtracking has a exponential time complexity. Because the reason is simple, you explore all the steps, or you explore all the paths. Okay, so for example, let's take an example. So let's say from A to D you want to reach. From A to D intermediate you have three steps, B, C and E. Okay, so from A you can go to B, B you can go to D. Okay, from A you can go to B, B from B to C, C to D, or you can go from A to B, B to E, E to D. Okay, similarly you can go from A to C, C to D, or you can go from A to C, C to E, E to D. Okay, like this you will explore all the paths in backtracking. Clear, Gaurav? The intuition is clear. In backtracking, what you do, you just keep on reversing the last step and you explore what else can I do.
Yeah.
Okay, there's no optimization or anything in consideration. Just
No,
possible.
in backtracking you don't do optimizations. The optimizations which is in your head, we do that in DP. So for example, like there will be many steps which we will repeat while doing backtracking. Okay, like from A to B, B to D, A to B, B to C, C to D, right? There will be many overlapping problems. In backtracking you don't do optimizations, you do those optimizations in DP. Backtracking is just brute force.
Anis, can you please give an example of backtracking, like any
We
small
will do a
example?
sum, we will do a question. So let me just present the question. Just a moment. Yeah, so let's say we are doing this. Okay, so what does the question says? First, let's read. So the question says that you were given digits. Okay, so initially before smartphones we had keypad phones, right? So using 2 we could type 3 letters, using 3 we could type 3 letters, using 4, 5, 6, 7, 8, 9, using every letter, sorry, every digit we could have typed 3 letters, right? Okay, so here they are telling that you are given a input. Shit, man. Sorry, sorry, just I got disconnected. Yeah, so as I was telling, we will discuss this problem, which is letter combinations of a phone number. Okay, so before smartphones, am I audible, right? First of all, yeah.
Yeah,
So
yeah,
before
you are audible.
smartphones we had keypad phones, right? So using a single letter, which is 2, 3, 4, 5, 6, 7, 8, we could have uh, typed 3 letters. Okay, so using each digit we could have typed 3 letters. For example, using 2 we could have typed ABC, 3 DEF, 4 GHI, and so on. Okay, so now the question says that you are given a certain number of digits like 2 and 3. So what are the words you could have typed using 2 and 3? The question is clear. Like using 2 you could type, you can type A, B, and C. Using 3 you can type D, E, and F. So if you type 2 and 3, what letters or words can you type? So let's say if I type A using 2 and D using 3, I get AD. If I type A using 2, E using 3, I get AE, and so on. Is the question clear?
This is like permutation and combination.
Yeah.
No, there is no permutation here. The order is the same out here. Okay, like you have to type 2 before 3 only. I am telling what possible words that you can type. It's combinations, not permutations.
Right.
Okay, so just a moment. Is my screen visible? Okay,
Yeah.
just a moment. Just give me a moment. So what are the, so before I tell, like what's your intuition? Anyone?
Run to loops, take first character, take every other character from the next one, and
So
do
how
that.
do you do this? Like what I'm trying to say that that's quite obvious. Like I'm telling about algorithm intuition. Like let's say how means just tell me the approach which you are, which is in your head. Anyone?
Acha, Anis, always the output length will be like of two string only,
No, no, no. It can be 3 or 4 as well.
3, 4, or anything. Na, 6.
Yeah, it can be let's say 2, 3, 4. So let's take an example of what will be the answer for like 2, 3, and 4. So 2 represents ABC, 3 represents DEF, this represents GHI. So it can be ADG, ADH, ADI. Similarly, we can do AEG, AEH, AEI, AFG, A F H A F I. Okay. Similarly, it will be for B and C as well. Okay. So how do you do this?
Yeah, so I think that we will recursively call the function, and we will find the base case of the last digit, like the length of the input, and then we will, when we reach the base case, we will push the answer into a vector, and then we will backtrack from there.
Great. So before that, so tell me that if I tell you that, let's say the question is 2, 3 and 4, okay? Or let's say after 4 even there is 5 and 6, okay? So if I tell you that I have a black box, or let's say I have a special instrument which gives me the answer list, or which gives me the arrays of the words which will be constructed using 3, 4, 5, 6, can you extend it to using 2? Like, can you use this list and make the answer for 2? If you understand this, the recursion, backtracking, DP, all will be very easy.
Anish, please repeat the question.
So let's say I tell you that I will give you the answer for 3, 4, 5, 6. Basically, I will give you the list of words which can be formed using 3, 4, 5, 6. Okay. I will give you this list. You don't need to calculate. Can you, using this list, can you calculate the answer for 2, 3, 4, 5, 6? If I give you the list for this,
Yeah, I'll add 2 in every.
you will
Each
add
I'll 2.
2.
Add all the characters and two.
Each element of the 2.
Yup. So first we will add a at the, so we will do 3 operations here. We will add a at the beginning of every character. Then we will add b at the beginning of every word. So we will get, and then we will add c at the beginning of all the words. Okay. So let's say if this set of 3, 4, 5, 6 would have generated x number of words, so there will be 3x number of words if we add 2. One will be with a, one will be with b, one will be with c. Okay. So what I'm trying to say here is that, so let's say with 3, 4, 5 and 6, you have the words like, let's say anything. I am not getting into the digits. So let's say you have x, y, z, p. Okay. So we can simply add a at the beginning, and this will give us one of the words for 2, 3, 4, 5, 6, right? So if we add a in front of every words from this list, we will get the answer for 2. Similarly, we will add b, we will add c. Then here, till here it's clear, everyone?
Yeah.
Other people.
Yeah.
Yes, sir.
Okay, great. So now what's the recurrence relation? Tell me. Let's say f of 2, 3, 4, 5, 6. How can we write this with f of 3, 4, 5, 6?
We can iterate a loop over
Okay, we will iterate a loop. We will iterate over for I
to length.
from A, B and C, okay, which is the letters of 2, right?
Then we can concatenate each character, each of I.
Yup, we will add I plus Fi. So the recurrence relation is f of A, B, C, D is equal to I plus f of B, C, D, where I will range, or where I will be iterating from the 3 characters which I represent. For example, for 2 we could have typed A, B and C, right? For 3 we could have typed D, E, F. So this list will be these 3 characters, whatever A is. If A is 2, we will have A, B, C. If A is 3, we will have D, E, F and so on. Okay, so the recurrence relation is clear.
Yes.
Other people, Shubham, Tarun, Yash, Don, Subhra. Is clear? The recurrence relation derivation is clear?
Yeah, recurrence relations understood. Can you please repeat the? Uh, can you please summarize once? I mean, I understood, but just trying to get it in my head once.
So basically what I'm trying to say here is that the recurrence relation, so let's say if I want to find the values of 2, 3, 4, 5, 6, so I will simply iterate over the letters of 2, which is A, B, and C, and I will add every letter with the words of 3, 4, 5, and 6, just as I told here. I will add A once in the front of every word, I will add B once at the front of every word, I will add C once in the front of every word. Okay. So I will be iterating through all the three letters which 2 corresponds or maps, which is A, B, and C, and I will keep on adding them in front of the words returned by 3, 4, 5, 6.
Got it.
Cool. So this is our recurrence relation. Clear, everyone? Now what will be the base case? Come on, fast. What will be the base case? So let's say if there is nothing, if it is empty, what we will return?
Empty.
Empty string.
So this is the base case, simple thing. For identifying base case, always try to find a case whose answer is very obvious or whose answer you don't need to compute, you can tell at once. Okay. So what will be the, now you have the recurrence relation, you have the base case, how do you construct the function or the program? Let's say I name the function as letters. Okay, I will have a string input or a string parameter called word. So what I am doing out here was my recurrence relation. I will iterate over the letters of the first letter in word. Okay, so I will iterate for I is letters of word 0, right? And then what I will do, I will add I and call the function with the rest of the letters. Okay, so I will add I plus letters, sorry, just a moment. Okay, so first I will call this function with the rest of the letters. So let's say ARR gives me the array of words with letters with words. Okay, so this gives me the words which the letters from index 1 to 0 forms. Okay, like BCD, if I take out A, what will be my answer with BCD? So that will be stored in the array ARR. Okay, so now I will iterate over all the words of ARR and add I. Okay, so for let's say J, we will iterate from 0 to ARR length minus 1, and we will update ARR. Basically we will add I plus ARRJ. Okay, and we will return this answer. Answer can be, we can initialize as empty in the beginning. Okay, so the code, so tell me who hasn't understood the code till here. See the recurrence relation, see the code, and tell me, think for 2 minutes, see the recurrence relation, see the code, and tell me if you have doubts. Anyone has doubts like
Anis, can you please explain the last, I mean the inner for loop?
this one?
Innermost for loop.
So you have understood what ARR returns, right?
Yes, yes, yes.
So with ARR, so in with every word in ARR, I am attaching I so that I get the whole word. Okay. So what we did it here, that with every word in the array, we were adding A in front of it, then we were adding B, right? So A, B, and C is I here. Okay, like we are iterating over A, B, and C. So we are adding A in front of every word, right? So we are adding here I in front of every word, where I is the iterator over the words or the letters of the first character.
Okay, got it. Got it.
Others?
So I'm not able to understand how we are storing this in the array.
We are storing it using this.
Like after calling the base function and the recursion function, how we are storing.
What, how we are storing? Like we are making the array here, right? We are making the array for the string word in answer, and we are returning that array.
So what we are doing in the first for loop.
We are, as I told, we will be iterating over the letters of the ith of the first digit. Okay, so for example, if we have 2 in the first digit, we will be iterating over A, B, and C. So I will be A comma B comma C. We will iterate over A, B, and C.
Okay, sir.
नहीं समझ आया तो फिर से बोलो, लाइक पूरा कोड
No, sir.
समझ
Try
आ
run
गया
कर
ना
सकते क्या?
तरुण?
Yes, sir.
समझ आ गया
Yes,
ना?
sir. If you can dry run or
ठीक है, एक
something.
ड्राई रन कर लेते, एक ड्राई रन कर लेते, बेस्ट होगा. So let's take the example of 2 and 3 only. ठीक है? So let's, so initially what we will call letter 2. ठीक है? तो अब लेटर्स ऑफ टू, लेटर 2 में क्या क्या हो रहा है देखो. आई विल बी रेंजिंग फ्रॉम ए, बी एंड सी, राइट? क्योंकि टू कॉरेस्पॉन्ड क्या करता है, फर्स्ट डिजिट ऑफ 2 एंड 3 इज 2, ठीक है, विच इज वर्ड 0. ठीक है, सो 2 का लेटर क्या क्या है, ए, बी एंड सी, राइट?
Yes, sir.
तो आई विल बी इटरेटिंग ओवर ए, बी एंड सी. तो what will be ARR? ARR will be what we get from letter from 1 to end, right? From index 1 to end. So we will take the last one, which is 3. ARR is the array which letter 3 function will return to us. ठीक है? अब देखते हैं लेटर 3 क्या रिटर्न करता है. ठीक है, सो लेटर 3 में क्या होगा, व्हाट्स द फर्स्ट डिजिट इन 3? इट्स 3 इटसेल्फ. 3 का लेटर्स क्या क्या है और 3 का कैरेक्टर्स क्या क्या है, डी, ई, एफ, राइट? सो आई विल बी इटरेटिंग ओवर डी, E F. ठीक है. And what will it call? It will call letters, words from the index 1. Okay. तो इसमें क्या कॉल होगा? लेटर एम्प्टी स्ट्रिंग. ठीक है. सो एम्प्टी स्ट्रिंग क्या रिटर्न करता है हम लोग को? एम्प्टी एरे और एम्प्टी स्ट्रिंग. ठीक है. यहाँ तक क्लियर है तरुण?
Yes, sir.
अब देखते हैं नेक्स्ट क्या होता है. तो दिस इज द ARR विच लेटर एम्प्टी स्ट्रिंग हैज रिटर्न टू अस. ठीक है. तो हम लोग क्या कर रहे हैं? फॉर j ओवर ARR लेंथ -1 वी आर एडिंग I प्लस ARR j टू द आंसर. ठीक है. तो हम लोग एक बार समराइज कर लेते हैं. I विल रेंज फ्रॉम DEF एंड आवर एरे इज एन एम्प्टी स्ट्रिंग. ठीक है. फॉर दिस फंक्शन कॉल. ठीक है. तो वी विल एड D plus this which is D, E plus this which is E, F plus this which is F. ठीक है. And this will be returned by letter 3. So our array here will be this answer. यहाँ तक क्लियर है?
Yes, sir. Clear now. Total clear.
ठीक है. तो अब एरे अब वैल्यू ये हो गया. तो अब हम लोग ABC को हर एक कंपोनेंट के साथ ऐड करेंगे. तो इट विल बिकम. तो अब देखते हैं लेटर 2 के लिए कैसे कंप्यूट हो रहा है. लेटर 2 में I है A, B एंड C. ठीक है. और इसका एरे है दिस वन विच लेटर 3 हैज रिटर्न टू अस. सो DEF. So what we are doing here, so for every j or for every word in the array we are adding the characters of 2. So for A we will add A to DEF. So we will have AD, AE, AF. Okay. Then we will add B, BD, BE, BF. Then we'll add C, CD, CE, CF. Okay. And we will return this. So this will be returned by letter 2, 3. Okay. And this is our final answer. Tarun, clear?
Yes, sir.
Any other question? Okay, so time. ओके. सो टाइम कम्प्लेक्सिटी बताओ जल्दी जल्दी. अब समझ गए हो तो टाइम कम्प्लेक्सिटी भी लाइक यू शुड कंप्यूट द टाइम कम्प्लेक्सिटी, राइट? सो टेल मी व्हाट विल बी द टाइम कम्प्लेक्सिटी ऑफ इट. बताओ. ये सब बोलना पड़ेगा इंटरव्यू में. लाइक यू विल हैव टू टेल दिस इन द इंटरव्यू. Otherwise
n cube, where n is the length of the digits.
it's n
Cube.
sure.
This is exponential, right?
Tell me the exact value. It's exponential or not? Tell me the exact value. So it's very simple. So for calculating the time complexity of a recursion, first find out. This is also true for DP as well. Okay. First find out how many states will be there or how many iterations will be there. Okay. And for every iteration, how many time we are consuming. Time for every state. Okay. So how many states or iterations will be there? This is very simple. Tell me fast, man. How many iterations are we doing or how many recursion calls we are doing?
And total
N.
length of word.
Yes, because every time we are considering, we are taking the first letter out. Okay. So it will take us n iterations to take the whole string out, right? So number of states is n. And time for every state or iteration, what we are doing in every iteration. So we are running 2 for loops. this for loop will run for 3 times. How many times this for loop will run?
I think 2 to the power n.
Not 2 to the power n. For every digit, how many values do we have? It's
3 values.
okay. So let's say if I have 2 digits, how many possible combinations are could be present?
3 square.
Okay, so let's say if I have 3 square, okay, and so for 2 we have 3 9, so for 3 we will have 27, right? So this loop will be of the size 3 to the power n, 3 to the power n minus 1, because the length of this word is n minus 1, right? We are taking the first letter out, so 3 to the power n minus 1. If this word has n letters, or let's say n size, okay, so the first for loop will be running for 3 times. The nested for loop will be running for 3 to the power n minus 1, because for a length or for a size of n minus 1, there will be 3 to the power n minus 1 letters or words, right? So 3 into 3 to the power n minus 1 is 3 to the power n, okay? So the time complexity is 3 to the power n. The derivation is clear. It's very intuitive that you can simply say that 3 to the power n in the first place, the time complexity. But the interviewer, if asks you that how 3 to the power n is being derived, then you have to explain it like this, that the first for loop will run for 3 times, the second for loop will be running for 3 to the power n minus 1, because there will be 3 to the power n minus combinations of word that will be formed. So 3 into 3 to the power n minus 1 will come out to be 3 to the power n. So for a word of length n, we will have a time complexity of 3 to the power n. And space, what will be the space?
So what about our n iteration that we have calculated, means n length of word?
So for n length, so that is okay, that is for n lengths is fine. But for the derivation here, so there are two kinds of iterations, okay? Like here you are, for every iteration, the length of ARR is changing, right?
Yes, sir.
Understand this very carefully. There are two types of derivations while doing recursion. This is the second type. There will be cases where the things we do inside the recursion is fixed, okay? In that case, what you will do, you will do number of iterations into the time needed for every iteration, okay? But in this case, the value or the size of ARR is changing, so the time for every iteration is not same. ठीक है?
Okay, sir.
So you can't multiply it by n simply here, because one iteration will take, let's say, very less time, and one iteration will take a very long time, because the length of ARR is dependent on the length of the number of, is dependent on the length of the string word. Okay, so every iteration has a different time in this program, okay? So you simply can't multiply it by n. So programs or like code where every iteration takes the same amount of time or has a constant time, in that case you can multiply the number of iterations into the time taken for every iteration, okay?
Okay, sir.
Okay, now what will be the space?
Order of 3 power n
Sure.
plus order of n.
Tell me the final space complexity. Three to the power n. Gaurav, Anikesh, Subhra, like tell me what's the space. It's very simple. Arnab, Shubham, Ritik. स्पेस क्या है? It's n into 3 to the power n because the number of words possible is 3 to the power n and every word has a length of n. ठीक है? So time is 3 to the power n, space is n into 3 to the power n. ये प्रॉब्लम समझ में आया सबको? I want a thumbs up from everyone. Otherwise, if you have doubts, speak up. Dawn, Yash. Yash has been very silent today. Okay, so to summarize, what you should keep in mind while solving recursion problems. What we did first of all. So, first of all, think in a manner that if someone comes to me and gives me the answer for this input, will I be able to compute the answer for the full input? Okay, so what I did in the first place was that, to summarize, when I was given, let's say 2 3 5 4 6, first I thought that if someone comes to me and gives me the answer for 3 4 5 6, can I use this and compute the answer for 2 3 4 5 6? Okay, so the first step is to think that if I get the answer for, let's say, some variable or for some input, let's say if I get the answer for y, can I use it to answer, let's say, a plus y, or let's say a minus y, anything? Okay, so if I get the answer for something, can I use that answer to calculate my final answer? Okay, that's the first intuition building thought process that you will do. Second, you will do is, once you understand that how you will use the answer of y to calculate the whole answer, build the recurrence relation. Once recurrence relation we have built, which we built it here, this one, then think that whether what will be my base case. Okay, now while considering base cases, keep in mind that base cases will be those cases where the answer is very obvious. Okay, that the answers which you don't need to compute. For example, in this case, if there was an empty string, the answer would have been an empty string. As simple as that. Fourth, convert the relation and the base case into code. And the fifth step is derive time and space. Now in time, there can be two things, as I told, where every iteration is taking a fixed amount of time. In that case, it will be number of iterations into time of every iteration. Okay, let's take an example of this quickly. So let's say there's a function x, base case is let's say x equal to 0, we return 0, and we call it as, and let's say inside every iteration we do it like this: for I in I iterates from 0 to, let's say, 4, and we call function x minus 1 here. Okay, So what will be the time complexity here? So function x takes 4 times. Function x minus 1 will also take 4 times, right? Hello everyone, audible? So here every iteration is taking 4 time, or let's say 4 iterations, okay? So for n number of iterations or x number of iterations, we will have 4x iterations. So time here will be 4n, okay? So in these kind of recurrence problems, it will be number of iterations into time of every iteration. So here the time of every iteration is 4. Since we are iterating over a for loop of 4, number of iterations will be x, since x is decremented by 1 every time. Okay, and the second one here is that where every iteration will take a different amount of time. Okay, calculating time for the second case is actually difficult. That's why I took this example. In this kind of examples where number of iterations is not fixed for every iteration, try to think how many total iterations it will generate, or how many total answers it will generate. Okay, for example, here we saw with n letters we will be generating 3 to the power n words, so the time complexity will be 3 to the power n words. Okay, so here think of the total amount at once, don't try to break it down. Okay, so this is generally how you do backtracking and recursion intuition. Okay, I think most of the things are clear. Great. So I think most of you are also doing recursion currently. So recursion and backtracking. So complete that. Next week we will be doing the intuition building of uh, graphs. Okay, DFS and BFS and shortest path algorithms. And like we will be doing it every Sunday from 2:30 to 3:30. And so I think that's it for this session. If you don't have any other doubts, we will meet again in Lead Code Weekly contest discussions.
Yeah, sure.
So मतलब समझ में आ गया ना सबको, लाइक कैसे अप्रोच करना है ऐसे टाइप ऑफ क्वेश्चंस को, लाइक हाउ व्हाट शुड बी
Yeah.
योर थॉट प्रोसेस एंड व्हाट शुड बी योर इंट्यूशन, और लाइक द procedure I would say for recursion problems.
Recursion understood very well the recurring solution that we got. From the backtracking side, I think the question that we picked, I think I'll have to try and first to understand it
Yep,
properly.
you have to dry run it first to understand. That's also a thing. First you have to dry run and understand what will be my path or what will be my recurrence relation and how can I backtrack. Yep, you have got it right.
Backtracking concept actually, I think once I try it will be very much I understood.
Cool. Cool, then I think that's all. You people can leave.
Okay. Bye bye. Thank you.